Hi, we are going to show you how to test relays through Doble test set, which is automated testing equipment from Doble Engineering USA. We will now test an overcurrent relay, and we will teach you how to make a test plan in F6 test 3.1. In the database, you can click over. It takes a bit time to load. Okay, we can click anywhere out here and say append, and you can write the new location, or you can say the location name. I can say Google, because this is for the website. Okay, double click that, and again you have to append for the relay ID. Here you have to say relay. You can say overcurrent. You can write down the serial number of the relay. I don't have the serial number of the relay since this is a simulation. That's why I'm not able to give you any real-time testing, but still. I'm sorry for that. Let's do it once again. You have that relay over here, and you can write down the serial number. Okay, manufacturer. You already have a number of manufacturers out here, but if you need, you can add one more. Right now, we are going to do it with CSPC, and the model is IRI Pro. I would click enter, and if I double click this, a new screen will be generated. Okay, here you can enter the relay parameters. 50 Hz for the frequency, face-to-face voltage. It is not applicable for this relay because it is an overcurrent relay, so this vector is not at all going to be used, but this is important. Current IN means normal operating current. If it is 1 ampere, you can have 1, or you can write 5. Put a station name. Since I am doing as a simulation, I write Google, and I can say transformer 1 and apply. Now in this relay functions, you have to add the relay function, and you can add 50/51. These are the normal. This is the normal number for. This is the number for uh, overcurrent protection. So I'll click next. Here, this is a normal inverse curve, and that's why we would take the first one, face to neutral or face to face. After click modify, either you can select from all the manufacturers out here or one of those manufacturers, and I have already done this, so I will just write 1 into IN, because IN selected was 5 amperes, and the time which is set for on the relay could be 1 second. That's what I've set. This is the curve which is made out here. The output of the curve is this much. So as it is a 1.3 seconds relay, 10 times current would give you 1.3 seconds sharp. Click OK, close, and say yes to save changes. If you want to do a face-to-face testing, if it's a 3-phase relay, then you have to copy this and paste it. You have to copy and paste it over here, so that you don't need to do it once again, the entire procedure. Close this, say yes, go to test plan, create append. You can write here 50/51 name. Here you have to select iCare, comments. You can write your comments. I would write new and I would press enter and say OK. Here you get both of them 50/51. Sorry, 50/51, but face to neutral and face to face. Go to test configuration. You have to select the triggers and for just 2 seconds. 12 seconds could be less time, otherwise I would get an FSD, that is fault duration short. Okay, and I say now over here either you can click on the points which you want to test, double click, double click, double click, and these will be entered over here, or you can also take a multi-point. You can have a start value 2 and value say 5 and step value say 1, so get 1 2 3 4, that is 2 times, 3 times, 4 times and 5 times of the current means normal current. So if it is 2 amperes, if it is 2 times, it's 10 amperes because the IN is 5 amperes. 3 times 15, 4 times 20, 5 times 25. Please remember, double test kit is well for a 30 ampere test. So 25 amperes it can test. You can also have a sixth one, that is, you cannot have a 10 times IN. You can have a sixth one over here, and after this is done, go to test. So you have all these values out here before it, which it can be tested. Now AB, BC and CA is not there, so we have to create test points for face to face and three phase as well. Over here also start value will be 2, end value will be 5 and step value is 1. Say OK. Same for three phase. Add multiple points 2, 5 and 1. And there your job is done. Okay, this will show you the phases. You can keep them alive for you. You have to have the fault type A, N, B and CN, AB, BC and CA, ABC. For making this video shorter, I am going to do one of A and BN, one BC and one ABC, so that when these points are being tested, you can observe what is being tested over here on the screen, and I would have an offline simulation mode since I don't have the test kit connected with me. Next time I'm going to test a Schneider make relay, and I will test it with the software along with the relay, but this is just for the test purpose to show you how it can be done. So I have to just click run and the testing begins. You can see IA is now 3 times. It is already tested 1 point. Now it is 4 times. It is 20 amperes. It is 5 times now. That is 30 amperes. 6 times. Yeah. So TTD means I am not able to test that because my source is lesser than what it is supposed to be. I have a 30 amperes test kit. Again, now it is being phase B and C. That's why you are able to see 25 amperes in both the phases at 225 degrees and 45 degrees. After this is done, now we are going to be 3 phase voltage, 10 amperes in each phase, 15 amperes in each phase, 20 amperes and this is for 25 mp. Okay, now this test is completed, and you can see the tolerance angle and also see the actual characteristic. This is the way it can be done, and I thank you for watching this.